Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Tonight we're going to take a look at some tips to generate student success on that SAT exam. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make those tough to teach, tough to learn concepts accessible to all my students. And tonight we're lucky to be joined by our panelist, Tom Reardon. Excuse me. Tom currently works for Texas Instruments as a product support and development employee, but had been teaching for, I think, a mere 35 plus years, taught high school math and as well as collegiate level math as well. So Tom, thanks for joining us.
Sure. Hi, Mike. How you doing?
I'm good. Hey, Tom, will you get us started by talking over some of the agenda points for tonight?
Sure. So we're going to look at the SAT experience. We're going to do some actual SAT test items from 2021 and 2022. I was able to secure some actual tests. You're going to get over 30 questions and activities to help prepare students for the SAT on a PDF. And sounds like we're going to have a drawing. What are we giving away today, Mike?
We are giving away to one lucky winner at the end of the webinar a T-Cubed International Conference registration for the virtual international conference this summer in July.
Oh, good, good.
So we're expecting a large crowd, so your audio is muted. Feel free to send any questions you have for Tom using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Tom, let's get this party started. Feel free to share your screen.
Okay. So from what I understand, this is the last webinar of the season. Is that true?
Last webinar of the spring season. Yep, we'll be back on Tuesday nights in July, I believe.
Okay, all right. So I think Mike told me in the practice session that I'm the caboose, so I take that with pride. All right, so always start off with a quote. Whether you believe you can or believe you can't, you are usually right. And so, excuse me, some of you might not even know who said this. Good old Henry Ford. And this one, success doesn't come to you, you go to it. Okay, so those are my two quotes for this evening. So top 4.75 tips to generate student success on the SAT math test. One, get students to think graphically and also by table. The power of visualization is huge, okay? Students need to be very comfortable with the calculator, use it effectively and effortlessly. So some teachers say, well, just the week before the SAT or ACT, we do a calculator thing. I'm thinking, no, they have to, it's got to be part of them, okay? So that they just know how to use it. I'm hoping that you use the calculator not just as an answer getter, but also as a teaching and learning tool. And we strongly urge you to at least one problem per day. Not what you're teaching that day, but they've had background to do it. Get them used to this because the questions are asked so very differently from how we ask them in our classroom, how they're asked in your textbook. So get them used to those questions. And my 4.75 tip is if the calculator does not help, well, I can't finish it because it's only 3/4 of a thing, but don't use it would be my suggestion, okay? So how I use the graphing calculator in my classroom or did and encourage others to do so when I teach teachers as a teaching tool and as a learning tool. Help students discover patterns, look for patterns, discover formulas, check answers to solutions, visualize graph and visualize solving equations. Can't say that enough. It's more on the SAT than on the ACT. That's a big deal, by the way. To solve tougher application problems that are impossible to solve what we call by hand. The equations might be solvable, like some kind of cubic or quartic. We don't know how to do that. And also as a tool to review concepts. And I love to use what I call electronic flashcards. So those are ways I like to use the graphing calculator. So how I prepared for tonight's webinar, if any of you were on my ACT one before, it's very similar. I took 4 recent SAT tests from 2021 and 2022, just the math part that is. So that's 232 problems that I did in various ways to help prepare for this. I cut each question and sorted the problems into piles of similar types. And so this is what my desk looked like, okay, next to me there with these problems. And so this is a see what is possible session. I'm not going to train you on how to use the calculator. It's more of a, what's possible and what you can do. Since I may be going too fast, I pre-did all the problems using both the 84CE and the TI-Nspire CX, and I created a PDF with all those solutions. So if you're unable to keep up, there's hope for you. You have access to those solutions. Now, when the 84 and the Inspire were very similarly done, I just showed the 84, but when the Inspire was significantly different, I showed that as well. I'm also supplying a PDF of all these activities and sample problems that we do so that you can have these with your students if you want to use them. Okay, I think there are around 30 of them. Okay, and they're all accessible. I should point out the SAT does not allow us to use actual SAT test items. So I needed to create very similar test items as sample, very similar, okay, without copying them exactly. So this is the link right here. Mike, you might be able to put that into the chat. It's K is case sensitive, bit.ly / T3 SAT caps, and then webinar. Okay, so that's our website. And on there, there'll be, like I said, the PDF of the presentation with both of these solutions. Okay, what you're looking at now, basically. A PDF of the problems that we did so you can do these with your students. And I'll point all these out at the end as well. I also found a link to 8 complete SAT practice tests from the College Board. Okay. And so I'll point those out. Transformation graphing is huge for this test. And so I'll point you to TI's video series there. And Becky Kaysen, thank you for your help there with that. I see you're on. Becky helped with testing those materials. And then I have an ACT workshop in Columbus, but that doesn't really apply to probably any of you if you're since you're ACT people, but just in case. All right, so important in the chat, please vote. Please be American, full-blooded Americans and vote. So please type in the chat just either 84 if you prefer the 84, N if you're inspired, just N, and then E if you use either of them. That way I'll know, where my audience is. So 84, N or E. And then Mike, you can kind of give me a ballpark on, what the people prefer.
Yeah. Let me give me a second
And I
to kind of look
appreciate you
this over
voting.
real quick.
No, that's okay.
So I'd say we're heavy on 84 with a bunch of E's sprinkled in.
Okay. Okay. But we do have some people strictly inspired too, I guess.
Yep.
Okay. So I will point out the Inspire things. I'm going to stick with the 84, but the questions are independent of it, but the technology there. Okay. I should also tell you this. I really want my students to be able to do all these by hand. But since it's a high stakes test and if they're allowed to use them, I want them to use them to their advantage. Also, as a teacher, I like to use this as a teaching and learning tool, even though they can't use it on a particular question. That doesn't mean I can't teach that concept with a calculator. So that's kind of my disclaimer there. So with that, let's go ahead and get started. So my first topic that I had the piles of was think graphically. I would say this is probably the second highest topic on them. Okay, I'll hold off on the highest topic a little bit later. So I hope you can read these okay, but again, you will have copies of them. So this is a calculator. C means calculator, NC means no calculator. And this is really more of an exercise, okay, to help students get ready for thinking graphically and how to interpret the calculator and so on. So this says, given this function right here, g of x, if possible, state the coordinate or coordinates of the x-intercepts, the coordinate or coordinates of the y-intercepts, okay? So let me go ahead and talk through those. So I'll bring up a trusty 84 here. And so in y equals, we'll go to y equals and clear out what's there. And I'm going to go ahead and type into y1 what you see there, the opposite of x squared minus 6x minus 5. And let me just double check that. You can see that there, okay? And my window, the window I prefer, this is my favorite window, by the way, for graphing. It's a square window. I also like the fact that it's gridded. So when I graph here, I have a nice grid there. So that's kind of what I like to graph there. That's the window I like, and that's the results I get. And so I can see the x-intercepts, but in fact, I can trace to them. But really what I like to do is when I'm doing this, I'd really like to see the graph and table simultaneously. So I'm going to go to mode and go down to full screen. Whoops, that wasn't so good. Try that again. Mode and go down to full screen and turn right and go all the way over to graph table. Press enter on graph table. Right there, it kind of blacked it out, but I'll go there. In fact, let me even go to the next page. I think I have some. No, I don't. Let me just go ahead and add a page for this. And graph table. And so now when I press second graph, you can see, and maybe make this bigger, I can see the table and the graph at the same time. And right now, this says 1, negative 12, okay? So let me kind of maybe go back through here since I'm going to go up here. And notice that I can see the point on the graph and see its coordinates in the table. And I think this is just tremendous. So here, this shows me that that's one of my x-intercepts. And as I continue to go up, here's my other x-intercept when y is 0. So I can go ahead and pull those off. And so graph table is really helpful to be able to visualize graphs with tables. Now, some of you might be saying, well, why don't you go ahead and just use the trace feature? Well, if you use the trace feature, watch what happens. Yeah, you can go along and see it in the table and stuff, but those aren't nice numbers. And the reason for that is I can control the table setup. Whereas on the graph, I usually can't easily do that. So that's why I said second graph to get to the table to be able to trace in the table and see the coordinate, see the corresponding point on the graph. So little tip there. All right, so again, I'll have in the directions here or in the notes, the square window that we want grid line and so on. And then we did the x coordinates already. We did the x-intercepts already. And this is what it looks like on the 84. And on the Nspire, it's pretty very similar, okay, there. But for the y-intercepts, let's go ahead and look at the y-intercepts. So that would be when the x coordinate is 0. So let me go ahead and go down here. And whoops, missed it. There we go. So I can see it physically there, and I can see the coordinates. Okay. So I can start making those connections. Okay. And again, that's what it looks like there. State the maximum value and where it occurs, okay, because that'll be asked on these questions, okay, what is the maximum value or the minimum value, and so on. So here, as I'm going through the table, we can see that this is pretty much the highest point at the vertex. And so here's how I prefer my students to state the answer. I prefer them to say this: the maximum value is y equals 4, and it occurs when x equals -3. So that there's no doubt what I mean. And I'm getting that probably more from my AP reading, as when students will say, it is this or it is that, not it. Y is 4 when x is -3, okay? And it's a maximum value of y when there. So I strongly urge you to do that. State the minimum value and where it occurs, okay? And as you can see here, there really is no minimum value, okay? It keeps decreasing there. By the way, my granddaughter, who's in first grade, called me on the phone last night and asked me what infinity meant, if it was a number. And so we had a nice discussion about infinity and decreasing and increasing without bound. I'm not sure she got it, but I convinced her it's not really a number. It's more of a concept, an idea. But anyway, all right, state the coordinates of the zeros. We kind of already did that. Okay, the zeros and the x-intercepts happen to be the same thing, but not all students realize that. Okay, so we need to have them do that. Now, factoring. I really like to have students factor using a graphing calculator when they're stuck, okay, to make use of the factor theorem. So for this one right here, if I go back to this, and I can see that there is a 0 here at x equals -1, and then also a 0 at x equals -5, that's where I can connect the zeros to the factors. So remember that if x equals -5 is a 0, that's because x plus 5 is a factor. And I talked to them, if you were going to set this equal to 0, you'd add -5 to both sides and so on. Similarly, this implies x plus 1 is a factor. And so our factor completely is right there, except I have to put a negative sign on it because it's going down. Okay, so I do like to have students make the connection between factors and zeros. All right, so also you might be asked to evaluate a function on the SAT at a particular number, and you may be able to use a calculator or not, okay? So I'd make sure they understand that. So for this one, I can actually just go down to x equals 3 and see that the function value is -32. And it doesn't have to be in the graph and table. I could also trace to the graph, okay, on it, okay? But one of my favorite places to do this is actually use function notation, and alpha trace is where all the y variables live, and do y1, which is g, left parentheses, evaluate at 3, right parentheses, and I get that same value of -32. So I think it's important that students see it both graphically by table and algebraically, okay? Now, the next thing I'm asking them is, oh, and this is, again, what it looks like, trace, table, function evaluation, okay? This is what it would look on Nspire. Those of you who are Nspires, you can see when I trace on Nspire, it actually moves the window so you can see it, okay, which is nice. And again, I can say since it was in F1 at 3, I can evaluate the function there as well, okay? So I did G at 3, but then in H, I said, for what values of X is G of X equal to 3? And unfortunately, in Ohio, the state where I taught my entire life, students think G of X equals 3 is the same as G of 3. Okay, that probably doesn't happen in the rest of the United States, but it happens in Ohio. So for those of you in Ohio, what I would suggest you do is actually have them see that by going back to here and then saying, let's graph G of X equals 3. That is Y equals 3. And I can see that there are 2 points of intersection, okay? And I love that, again, with this graph trace, a graph table thing, is I can actually just go ahead and see them. And so let me do the second graph, which is table. And I can see that, whoops, went too far. Right here at -4, I'm getting 3, that 3. And also at -2, I'm getting that 3. And seeing it in the table, you can see that, that has those values. So I'm able to get those, solve the equation that way, okay? So I think that's important. And I love to teach solving equations by graphing first, even before I do algebra, so they can start to visualize why there's 2 solutions or only 1 solution or whatever, okay? So then this is kind of what your notes will look like, or a key will look like that you can download. On the Nspire, you can actually find both points of intersection using the geometry intersection point tool. You don't have to do one at a time like you do on the 84, okay? So little bonus there for Nspire. For what values is a function less than 0 or greater than 0? That's another question that comes up on the SAT. And I want students to feel comfortable both without a calculator and with a calculator. So here on this one with the calculator, let me go ahead and turn off the graph table and go back to full screen because I don't really need the table for this. So I'll go back to that full screen. Let me actually turn off, no, even clear out x equals 3. I don't, y2 equals 3 rather. Okay, we're a third of the way in according to my phone. So I can see physically, and I want students to see that this is where it's negative here and negative here. But to really make a big deal of that, I think this would be a great place to use the inequalities app. So I'm going to turn on the inequalities app, and because that allows me to graph things like x is greater than or equal to, less than or equal to. And I think what I'm going to do, I'm going to shade everything in brown. And what I'm going to see, I think I need an x is less than. So let me go with that. So I want x is less than -5, I think, if I remember correctly. And then this one, I'll go over here and change that color to be brown as well. And this time I want it to be x is greater than -1, because that's where those intercepts were. And so let me go ahead and graph that. And I love this fact that it's really highlighted to me and the student that where this is shaded, the graph is negative. The values for g of x is negative. And so putting that algebraically, I guess I did it in green here, x is less than -5 or x is greater than -1, okay, using the inequalities app. And then on the Nspire, I did this in 2 different colors to kind of highlight the 2 different colors there, okay, to see where it's negative. And then where it's positive, where the function's positive, I decided I'll use the same thing, but it's where it's not shaded. So between -5 and 1 is where the function is definitely positive. And similarly here as well. So if you've not thought about doing that to help students visualize better, I strongly urge you to do that. All right, some sample test items from 2022 and 2021. So again, this is number 20 from a test in 2022 or 2021. I don't remember which one. It's a calculator one. It was really close to this one, but I couldn't use it exactly, so I created my own. Okay, but it's pretty doggone close. All right. So for this one here, so I'm hoping students can do this without a calculator. But again, in fact, let me go ahead and turn off that inequalities app. I don't need it anymore. There's several ways to turn it off. And I also don't need this anymore. So it says the graph of y equals the opposite of the quantity x minus h squared minus k, where h and k are positive constants. That's a big deal, by the way, is a parabola. In which quadrant is the vertex of this parabola? This is thinking graphically. Okay, so I'm going to give you just a few seconds to think about it, maybe not enough, so don't get mad at me because I have a lot of things I want to share, but I do want to give you a chance to at least think about starting solving that. So a few seconds there. Think about it. Don't know, you don't have to put your answer in the chat, throwing people off. Let them think about it. All right, so what I'm going to do is I'm going to just assign values for h and k. They have to both be positive constants. So I'm going to type in the opposite of the quantity, x minus +3, the quantity squared, minus a +4. So those are my h and k, 3 and 4, okay? And then I'm going to go ahead and graph that. And, oh, did I not type that correctly? Oh, I did not graph that correctly. Instead of being squared, I typed in, well, I better start over again. Whenever I make a mistake, that's not good. So the quantity of x minus +3, and I got to hit the squaring button, not the -1, minus a +4. And then I'll go ahead and graph that. And it's clear that the vertex is in quadrant 4. By the way, you'll have some students say the entire graph is in quadrant 4 and we need to talk about them, okay, or they need to talk to us or something like that. So that would be a way of doing this, being able to visualize, but using the calculator to help visualize that. And you could do that both on the Nspire or the 84. They're very similar. So here's one for you that's very similar but different. This was a calculator one. Which of the following functions has a maximum value of c, where c is a positive constant? So again, let me give you a few seconds to think about that, okay, before I show you my suggestions. All right, so how I decided to do this one was, again, since I'm allowed a graphing calculator, I assigned a value of c to be 3, and I graphed these, okay? I don't think you need to see me do this. I think you can kind of visualize this. So I used x squared, negative 3x, 3 minus x squared, and x squared minus 3, and graph those using these colors right here, okay? And so which one has a maximum value of that value c? Well, you can see in 3x squared, which is blue, there is no maximum value, so that's out. Negative 3x in brown, no maximum value. 3 minus x squared, okay, has a maximum value of 3, and x squared minus 3 has no maximum value. So this one is pretty clear, and 3 is that positive constant and that maximum value. So the answer is C. The question's not that hard, but I don't think I've ever asked a question like this in my classroom where I had variables instead of numbers. So if you do a problem a day, your students are going to most likely to pick up on that. Similarly on Inspire, again, the color coordinating is great. You can see all the functions right there on there. So with that, Mike, I've been talking for a long time. Anything popped up on the chat I should know about, or questions, or this is now a time people could ask if they have a question?
So far, the chat's going really well. We have people that are helping other people out, so that's always nice to see. But I didn't see any questions just yet. Again, like Tom said, if you do have some, feel free to get those in there, and we'll try and get those answered live.
Okay, thanks, Mike. And thank you for everybody helping each other. That's great. Okay, that's great. All right, here's another sample one. This was a non-calculator one, okay? It gives you y equals the quantity of 2 minus x times the quantity x plus 2 times the quantity x plus 3. It says the graph contains the point p comma q. If p is between negative 2 and 2 inclusive, which of the following is not a possible value of q? And they'll often make it all capitalized to emphasize when it's not, okay? So let you think about this one for a few seconds. Again, no calculator allowed here, okay? But I could see myself teaching these concepts with a graphing calculator. Now, it may not have been enough time, and again, I apologize, but I do want to get through things here. I've at least got you start thinking about it. So this one, since there's no calculator allowed, I thought I would make a sketch, okay, and plotted the zeros, okay. But when I first went to do this, I just thought, oh, well, go down here, up here, and so on. But I have to look at end behavior here, okay? So like I looked at as x gets very, very large in this direction, what happens to y? So I'm thinking like if x was 1,000, this would be like 2 minus 1,000, which would be a negative number. This would be 1,000 plus 2 positive, 1,000 plus 3 positive. And so when you multiply those together, you get a negative. So in this direction, this thing's falling down. And then knowing how polynomials behave, it's falling down here. It's got to come back up and come back down to a 0. And then it's got to kind of go back up through here. So I know it's a sad looking polynomial, but that would be it. But that's going to help me decide if x is between negative 2 and positive 2, which can't be happening. Well, 3 is in line, 2 is in line, 0 is in line on each of these. Negative 1's not happening. So that would be A. And this is thinking graphically. And we can use the calculator and good instruction to help students learn that. Again, I'm not sure I ever would have asked this question in my classroom, but I think it's a good one to get them going. By the way, when they come to a question like this, they originally say, my teacher didn't teach me this. Well, we taught you the concepts. We may not have asked this question, so we need to ask more questions like this. All right, units conversion, which is always in the calculator section. There's usually one per test. For about a year or two, they didn't have any, and now the last couple of years, I noticed they have them again, so that's why I included it. So as an example, let's go with this. How many inches per minute is equivalent to 3 miles per hour? Okay, and again, this is all of them are always calculated because there's a lot of multiplication and division you have to do. So let me give you about 20, 30 seconds just to start it, and then we'll come back and look at it. So go ahead. All right, about 5 seconds. All right, so for this one here, um, we're going to use what's sometimes called the factor label method or the unit factor method. And if you do this method, your science teachers, especially your physics and chemistry teachers, will love you for this because this is pretty much how most of them teach it. Now, there are some kids who can do these types of questions logically, and as long as they're correct, I'm fine with that. But this is kind of a procedure that works pretty well. So what can do is we'll begin with a given quantity, including the units, but we write it as a fraction. So in this case, 3 miles per hour, we'd write it as 3 miles divided by hours, okay? And then what we do is multiply this expression by ratios, fractions, that are equal to the number 1. And the reason we picked the number 1 is when you multiply by 1, you don't change its value, okay? So in this case, these would be ratios that are 1, an hour divided by 60 minutes, 5,280 feet divided by a mile, and so on. So those, when you multiply by 1, it does not change the value of the expression. So 3 miles per hour, I could first multiply 3 miles per hour by 1 hour divided by 60 minutes. We'd all agree that that is 1. The reason I picked it in this order, not the reciprocal, is these hours are going to divide out and make a 1. Okay, I don't like to use the C word, cancel. You make a 1, okay? And then I multiply by this fraction that's a 1, so that this mile and this mile here in the denominator and this mile in the numerator will divide out and make a 1. And then 12 inches is 1 foot, and this feet here and feet here will divide out. And I actually show this on the next slide here. And I also try to show how I divide them out and make ones. And I use different colors to illustrate that. So you can see that that is the case. And so what's left are these numbers in the numerator, this number in the denominator, and I'm left with inches over minutes, which is exactly what I want, inches per minute. So I know that I'm in the right spot there. Okay. And so I go ahead and multiply those out and divide them and so on. A calculator would come in real handy. Hopefully you'll trust my um, uh, calculations there. You can see this would be a grid in, by the way. Okay, this is a grid in answer. And I did see somebody pop up and said, bless you. I missed the first part. I just saw the bless you. Hopefully I didn't sneeze. All right, so here's a sample test question. It's allowed the calculator. It's fairly simple. It's using a furlong, which we all don't know anything about. And it says a length of 5 furlongs is equivalent to how many centimeters? Okay. It does tell us what a furlong is in meters, but it's not telling us anything about centimeters. I guess they're hoping we know about that. Okay. So again, let me give you about 30 seconds to start that, see what you can do. Okay. Get a sense of that. All right, 5 seconds. All right, so for this one, I would start off as 5 furlongs divided by 1. That's my fraction template. And I'm going to multiply it by this number 1, 201 meters divided by a furlong, so that these furlongs will divide out, okay, and make a 1. And then I have to multiply by 100 centimeters divided by a meter, because a meter is 100 centimeters. And I want these again to divide out, okay. So when I divide out the common units, okay, and make ones, I'm left only with centimeters. And when I do the calculation, I get 100,500, which is letter C. Again, not a difficult one, but for some students, it could be, I have no idea. So there's units. All right, so function evaluation, we did a little bit of this before, okay? So it's calculated as many ways as possible. F at 5. We kind of already done this, so I'll just show this. F at 5, I could graph and trace to 5. I could go to a table. I can do evaluate function. Though I guess I haven't shown, did I show table ask? I don't think I did. So let me go back to that one. For those who've not, because I really like the table ask method. So in Y1, I'm going to go ahead and type in x squared minus the quantity of 3 minus 2x. So there's my f function putting into Y1. Make sure I type that correctly, okay? And if I use table ask, I'll go to second window, and under table setup, if you go to the independent, which is the x variable, and press enter on ask right here, then when you go to table, you can just ask for the numbers you want. So like 5, there it is. 2. That way you don't have to scroll if you want a really big number or a number that's like a fraction or a decimal. Love the table ask mode. So that's several ways to find the function's evaluation. And on Nspire, again, graph and trace, table, evaluate function, those are all pretty straightforward. But the next part is calculate in as many ways. Oops, I guess I'm showing the answer here. I didn't mean to do that. So that's a goof on my part. Sorry about that. So here, let's go this way. Calculate many ways possible the value of x where x is equal to 5. Okay. And so I guess I will just show them. I typed in both of this and then when it's equal to 5. And again, I can just use intersection. We've done that before. Okay, that's pretty straightforward. And I want students to be able to think that way, visualize that way, maybe not solve it that way. Okay. But then on Nspire, again, you can find both points of intersection at the same time, which is cool. All right. But what I also want to show is numeric solver. Okay. I think that's important that you see numerical solver on both the 84 and on the Nspire. So if you're not using, and by the way, I hated this. I hated showing my students this, but for this test, they're allowed to use it. I want them to use it. So let me go back to table setup and go back to automatic because I usually prefer my table to be automatic. All right, so on the 84, if I go to math and press the up arrow to the very last feature, it's numeric solver, okay, right there. And when I press on numeric solver, it pops up with E1 and E2. Now that's not equation 1, it's expression 1 and expression 2. It looks like I already did this. I already populated with the left expression equals the right expression 5. So once I've typed that in, you'll notice there's OK above graph. So if I press graph, that means OK. All right. And now if I want to find an answer, I have to give it a seed or a guess. So I'm going to go ahead and guess with, let's say, 10 and say I want the one that's close to 10. And then solve is graph, so I'll press graph. And so when I tried 10, 2 is the closest one, okay, which we kind of already knew from graphically. And then if I want to find maybe if there's a negative one, I might try a guess of like negative 10. and then try graph to solve. And notice here, I'm getting like, oh, let me see it better. I'm getting negative 0.40000 because this is doing an algorithm, so it's not exact, okay? It's doing an algorithm, but it's close enough to -4. So I do like having the numeric solver for this test. I don't like my students using it otherwise. I'd rather they did things by hand, but that's just me. And there's also a numeric solver on the Nspire. Okay. The difference there is your seed is typed in right here. So it's nsolve, the equation equals, comma, the variable equals what you want to seed it with. So I tried 5 and got 2. I tried -5 and got -4. So Nspire users, you also have the numerical solve. Let me stop there and see if there are any questions. Mike, anything going on I should know about?
There's a side conversation about furlongs, which is interesting. I think Josh had asked about a minute ago that we're only limited to 2 expressions.
Oh, okay. Yes. Because there's only 2 sides to an equation. Okay. You set one expression equal to another one. So, yeah, those are the 2 expressions. Expressions are on each side. So, thank you, Josh, for asking a question. Yeah. So, I didn't give Pez's away tonight for questions, but in my heart, they're there for you. Okay. All right. So calculate in as many ways as possible f of g at -5. So again, I'm going to point out some things, but I do want to illustrate something too. But so here, well, no, maybe I better show this. I got to show this. Sorry. Even though it's time, I got to do it. So f of g at -5. So let me go back to y equals, and I've got f in y1. I need x plus 3 in y2. So I've got those there. Okay. So I'm going to go ahead and graph them. So I've got that. Okay. So stay with me. I go slower with students, but I want to find f of g at -5, which means I want to evaluate g at -5. So I'm going to trace, but I need to get to the red function first and then trace to -5. So I'll type -5, enter. And when I do that, -5 gets me -2. So that's my y coordinate of this thing here, but it becomes my x coordinate for f. So now I want to trace to the blue function to -2, and I'm getting -3. Now I know I went a little quick there, so I went ahead and put this in this way, thinking this might help. Again, I traced to -5, got -2. Then I used that in my x in my blue to get -3. So I think it's a really good idea to see how you're going from graph to graph. This could also be done going from table to table. Okay, so I set up a table here, a full table, not a graph table, a full table. And I said, if I put in -5, I get -2 in my g function. And then go to -2, I get -3 in my blue or y1 function, my f function. So again, I can show this by table. I don't think it's as nice as graph, but some students might relate to it. Again, one of my favorite quotes is, I'm not sure if my students, I'm not sure I can teach in as many ways as my students can learn. Okay, there's always more ways I need to find. So I'm looking for those. Okay. Now I can also do y1 of y2 of -5. Okay, that one's kind of straightforward. But here's another one that I really like. See what you think here. Is in y3, I can actually type in the composition function. I can do y1 alpha trace, y1 of alpha trace y2 of x. By the way, the x's are optional, but not for me. I prefer to see them. And so now I'm graphing the composition function, and I can trace to that composition function when x is -5. And see, again, -3. Okay? So you got a lot of options there, a lot of options there, okay? Now going the other direction, G at -5, G of F at -5. Again, I did it graphically. I went to the blue one, got 12, went to the red one, 12, put in 12, got 15. Did the same thing with graph with the table. You could see it on the table. Okay, so it's another option there. And then I also did the function composition as you see it normally, okay, using function notation. And I could also do the composition function, okay? But here's the part I want to go with next, okay? How about looking at C and D in a different way, okay? So on this one, again, I'm going to go back with this and let me graph this. So this is F at G at X, right, in black. This is my composition function in black. This was my quadratic in blue, and this was my X plus 3. What is the relationship between the blue and the black? What do I do to the blue to get the black function? Now think about that. What do I do to blue to get black? All right. So there's where I got that. Okay. So what do I do to do them? And the answer is I've moved this 3 units to the left, right? Look at this, the transformation function, x plus 3. It's a horizontal shift to the left 3 units. Remember, x plus 3 would go to the left 3 units. And my question is, can transformations be accomplished as composition of functions? We'll hold off on that answer because now we're going to go the other direction. Okay, go the other direction. I'm going to do y2 of y1, and I'm going to get this. So again, blue is my starting function. This is my composition of the two. What's done to blue to get the black? What's done to blue to get to the black? And you can see we've shifted it up 1, 2, 3 units vertically, which is what this would be going vertically. Okay? So my question again is, can transformations be accomplished as composition functions? The answer is yes, and it's something I'm looking at right now. I have been looking at for the last few months. But anyway, it's just opened up a whole nother line of thinking for me. So just throwing that out there. Okay. So test items from 20 and 22. Let me see where we are. I'm going to probably be skipping around and showing more ideas than doing them. So I want you to see them. Okay. So the value of the weight this function, there are many ways to do this. My favorite probably would be to just y1 at -6. Okay. On the Nspire, though, what I like about Nspire is that you can define a function, as I said before, just as you see it, and then do h at -6 just as you see it. So I do like that part on Nspire. This was one I thought was kind of interesting. Which of the following is expression equivalent to P of Q of X? So here's P and here's Q. So this one is asking you to do composition, but not in terms of a number, but in terms of a variable. Okay. So I think we could all do that algebraically. Okay. You'll notice that the answer in some cases is in factored form. Sometimes it isn't. Okay. So that would be another step for some students. But let me show you how I did this graphically. So I did this graphically using x minus 3. This is here, y1 of y2. And I did this graphically. And when I did that, the blue was the original, the black is the answer. And you can see that the equation of this is y equals x squared, but shifted 1, 2, 3, 4 units to the right from the origin. And so I can get the letter C graphically, okay, on this one. So even though if a student can't do it algebraically and they're on this high stakes test, this is a way of getting around it. And again, that's not what I'm after, but on this test, this is helping them at least be able to compete, okay? Also, I think it's just a great visualization tool. All right, so you can do it on the Nspire as well, okay, as you can see right there. All right, using structure is a big deal here, okay? And so here's a question, and this happens at least once on each test, okay, using structure of algebra. So here's a non-calculator. If x satisfies this equation, what's the value of 2x plus 1? And it is a grid-in answer. So since we're running out of time, sorry, I'll just go ahead and show you this. 24 out of 25 students will do it this way. Subtract 3 from both sides, divide both sides by 6, and be upset. Be upset that they have a fraction, but then they don't feel so bad because they have to substitute into 2 times that, so the fraction kind of goes away, and they get 10, and they're happy, and they're correct, okay? But usually about only 1 out of 25 students would say, how about if I just divide everything through by 3 and I'm finished? Okay. And you wouldn't believe the other 24 students, like you got their attention because they are like, I got to learn this math, whatever this is, I got to learn this. This is much quicker. Okay. So let me look at another example of this. So here's another example, okay, number 3, another non-calculator one, okay. So let me just 20 seconds, think about this, just 20 seconds, okay, just to think about it. And I'm going to show you what, again, 24 out of 25 students are going to do because we've kind of got them that way. I call this the traditional solution. They see this as a system of two equations, two unknowns, and I can't blame them. And they add them together and the y's drop out, okay? And they get x equals 17 halves and they're kind of discouraged, but, you know, they can substitute back and find that y is a fraction. Oh, geez, okay. And then they have to square them. Oh, no. And subtract them. Oh, geez. And they get 66, which is the right answer. Okay. But if they're using structure and they realize that x squared minus y squared is the difference of two squares, they just substitute the 6 and 11 and multiply them. And again, those 24 students, when seeing that, some of them want to, well, do bodily harm to me. And some of them are like thankful to me. And I remember one student who finally got it after we did about 4 or 5 examples, stood up in the middle of class and said, "You have changed my life." Okay. And I think she meant in a good way, okay, by showing her this. So using structure, I strongly urge you to consider that, okay, using structure. It's definitely, it's something some of your students are going to think about or do, but it's not something all of them do, okay? So for this one right here, here's a sample test item from, I think this was 2022. What is the value of x plus 5y? And I've got all these different ways you could do this, okay? You could solve it, you know, graphically. You could solve it by table. You could use the simultaneous equation solver, okay, and solve it that way, okay? And if you're not familiar with that, I suggest you get familiar with that, okay, and get the answer. And then the final answer is -4. And then you could also do it on Nspire. Nspire has a simultaneous equation and solver, okay? But if you use structure, and if you just take the top equation and subtract the bottom equation, multiply by -1 and add, so to speak, you get x plus 5y equals -4, and that's it. That's it. And they put those problems in, they concoct them so that those students that are thinking that way are going to get done quickly and make time. Okay. So be aware of that. Okay. Structure. Solving graphically. I'm going to have to talk you through this, but I hope you'll like this one here. So when I solved this graphically. I found the zeros, and the zeros were these awful, awful numbers, probably irrational numbers. Okay. Like 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2 or something. But it asks you what's the solution, what's the addition of those two solutions. So when you solve them, those answers are stored in the variable x. I go off and store it into some other variable to more significant digits, found the other zero, stored it into h, and added g and h and got 0.75, which was actually 3/4. So even though these are awful solutions, and if your students aren't really good with the quadratic formula or working with irrational numbers that are, you know, whatever, This is a way around that. Okay. I really thought that was kind of cool, by the way. Maybe I'm the only one. Does anybody else like that besides me? Oh, by the way, there's two variables you never store are X and Y because as soon as you go to your graph screen, X and Y change. Okay, so that's why you want to store them right away. Okay. Same thing with Nspire, except on Nspire, you store them right on the screen. Store the variable right on the screen. All right, most popular feature on SAT. Let me see what I have here. I have 5 minutes, and Mike needs a couple minutes. So words to symbols, as for years, has been the most popular thing. When I say words to symbols, I mean like they'll have words translated into a linear equation, an exponential equation, an inequality, a system of equations, system of inequalities. Sometimes they'll just have you translate it like they do here. And sometimes they'll say translate it and solve it. Okay, but this is by far the most popular thing on the SAT, words to symbols in some way or another. And this one kind of surprised me here. I do have the answers to these. And it says increased by 130%, and a lot of students are going to go with 1.3, but it increased by that. You got to remember the one it had before, so it's really 2.3, okay, and 20 with the initial. So be careful on that. They also love none, one, or infinite number of solutions, okay, on their to ask about that. And they ask it by doing something like this. If this system has no solutions and K is a constant, what is the value of K? So we're kind of going backwards. Usually we give them the system and say solve it and say, oh, it's no solutions or an infinite number of solutions or whatever. So this one, to do this one, I did it this way. You have to add the equations and get something like 0 variables is equal to some non-zero constant. So I multiplied through by 3, added it to here. And the only way this is going to be 0 on the left is if K is negative 15. Okay. So again, it's kind of working backwards. So I don't have time for the mean, median, mode, range, and all those. I'll just kind of flip through those. They do ask questions about that. And then also transformation graphing again pops up there. So let me just take the website and show you what's available there. Okay. Are we here? Here we go. So this is the website that I created for you. And so the PDF with the solutions are right here. This should look familiar to you. These are my slides pretty much, but with the solutions there. So you're welcome to those. This is the same problems, but in a is it 4-page or 6-page? 6-page PDF. No, 4-page PDF. So that you can use them tomorrow with your students, okay? And again, they're not exactly SAT, but they are really, really close. This is, you are able to, oh, I hate this thing at the top of my screen. Here we go. So I have 8 practice tests from the College Board. So when you go to the link there, these are the links. It's SAT 1, 3, 5, 6 up to 10. 2 and 4 are not there. But when you go there, this is what they look like. And I'll even tell you what page it starts on. So this one starts on page 36. This is an exact test from the College Board. And then they have the answers at the back as well. I'm also really big on families of functions and making sure students can do transformation graphing. So I will take you to this website, and if you don't look at anything else there, please look at the quick reference guide, okay? Because this will tell your students, what they need to know, okay? What is it? And they'll have a list of equations. If they can't graph these equations, go to this video, and somebody like me will explain that to you, okay? What else is on there? Oh, I also have my T84 tips and tricks, 17 of them. First is a PDF in step by step, and then I have a video. So if you want to learn some of the things I did here, they're right there. If you're an Inspire person, I just have one 20-page PDF that does all of these things step by step. No videos. I didn't get around to the videos. Sorry there. And yeah, I think that's pretty much it. Oh, finally, if you're interested in volunteering to test my latest project using the TI-Nspire, just send me an email and say you're interested in doing that. I'll contact you, and it's looking at a couple short videos and telling me what you think. Okay. Very similar to that idea about with transformations being composition of functions. So where are we? Oh, sorry, Mike, I only left you 1 minute. So thank you. Thank you, everybody. Have a nice May. Okay.
Thanks, Tom. I'll talk fast. So we promised one lucky winner a T-Cubed International Conference registration, and tonight's lucky winner is Oscar Jimenez. So Oscar, congratulations. We'll be in touch over email in the next couple of days to get you more information about that registration. To download a certificate of attendance, go ahead and click the link in the chat window. Also listed is the link for all the documents tonight, mine and Tom's. And if you're watching this on demand, go and copy that link into your favorite browser to receive your certificate. Tom, thanks so much. Awesome job putting all the documents together tonight. We appreciate it.
Sure. Have a good one, Mike.
And thanks everyone else for joining us tonight. We hope to see you back online this summer on a Tuesday. Have a great night. Stay safe.